Ready? Recording's beginning. So, now we're going to talk about something called two-way tables. You've seen lots of tables before. Tables are just ways of like charts that allow you to very efficiently put out information and make representations, right? It organizes the things that you're working on so you can see exactly what's going on. Okay? Remember that tables have rows. Rows go how? They go horizontally. Excellent. And you have columns, which go how? Vertically, right? Okay. And so we're going to create some tables, guys. We're going to create some tables with this information. So this is an alternative to the probability tree. Now, they aren't always interchangeable, but most of the time they are. Okay? But if your assignment says draw a probability tree to represent it, then we're going to be looking for the tree, right? If it says use a table, we're going to be looking for a table. But if it just says find the compound probability, compound meaning more than one, right? Using either, they're always connected using either and or. Good. Where and means you're going to do what application? Multiply. Or means you're going to do addition. Excellent. Boy, y'all are good. Okay, so anytime you do that, if they just say find the compound probability, then you use whichever one makes more sense to you. The general rule is that if they give you all of the probabilities, then use the table, right? Okay. If you're looking for some of the probabilities, then sometimes the tree. But again, there's no hard and fast. So you need them both in your toolbox. So we're going to look at some of these and look at how they're set up and how to use them. Okay? So let's go. So two-way tables. So two-way tables, so this should go in your notes, yep. Two-way tables, which are sometimes referred to, so you can put that in a bracket, contingency tables, are another way of displaying outcomes for multiple events. Right? So two-way tables, bracket, contingency tables, are a way of displaying outcomes for multiple events. Okay? All right. Good job. So, in other words, you're able to organize all of the information that's given so that then you can read it really easily. These are generally a lot easier to read than probability trees. But again, you can't always replace the probability tree with a two-way table. So be careful. Now, here's a classic example. We have a two-way table here. Notice it's called two-way table because you have rows going across and you have columns going up and down. Two ways, two directions, yeah? And you have information for each one. Now, look closely at how this information is presented. Plays rugby, doesn't play rugby, right? Those are the two possibilities for this scenario, and both of them are side by side in a row, right? Here, plays football, doesn't play football. Again, two possibilities that are related, so they go in a column right next to each other. So if you're talking about rugby, then everything about rugby should be in the same row, right? If you're talking about football, then everything about football should be in the same row or column. Could I have put football up here across and rugby here down? Yeah. Absolutely. They're completely interchangeable. There's no reason for one to be one place and one to be in the other place. Okay? You happy with that? Now, but if you put rugby on the top, then make sure it's all rugby there and all the data about football on the side, etc. Okay? So, good job. So like you're playing baseball. You don't play baseball. Do y'all play baseball here? No? Okay. All right, give me a game then. Netball, there you go. You can either play netball home or away, right? And you can either win or And it doesn't matter which one you put where, right? I could put home and away. I can put win and lose.
And tie. There's a tie.
Oh, don't worry about ties. We're winning or losing. We're playing it out. Okay, that's right. So you just keep playing. Yep. So, or I could put home and away up and down and win or lose up here. Again, doesn't matter. Is everybody okay with that? So you get a little leeway. Now, notice there's a column for everything there. Just going to get rid of all the writing. Now, there are columns for these. This is where these spaces are where the probabilities are going to go, or the numbers are going to go. And then notice there's a total for the rows, and there's a total for the columns. And in this spot, this box here, that's a total of the totals. Right? Okay? Right? Now, this total is incredibly important to you because it's the total of all of the outcomes. And why is it important that you know the total of all outcomes? That's the denominator of your probability fraction, isn't it? Okay? So remember, it's all of the successes, over all the possible outcomes. Well, this is all where all the possible outcomes are going to come from. Okay? For the whole experiment, for the whole thing. Everybody good with that? So that's a really important column, that bottom column over there. Now, sometimes they're going to give you all the numbers. Sometimes they'll give you some, and you can find the others. But what do you know about a total? Let's say I had a total of 100 here and 50 there. Well, a total means you're adding them together, right? Well, if you know the whole and you know part of it, what can I do to find the rest?
You can subtract the part of it from the whole.
Exactly. Subtract the part you know from the whole, and that'll tell you what's left, right? And you can do that up and down. You can do it across, whatever. Okay. So sometimes you might have to do a little addition or subtraction. What if I knew the parts, but I didn't know the total? Just add them up, right? Okay. So sometimes you're going to have to complete the chart before you can use it. How's that look? Okay, good. So you can see in this particular example, we've got our two-way table, but it's not complete, right? So I would like for you to put this in your examples, create this little table, and we're going to fill it in together. So this will be an example. So it's still the same one. Plays rugby, doesn't play rugby. Plays football, doesn't play football. And we're going to talk about it. So some of the data has been corrected, including the overall total, right? Down there at the bottom, the overall total is 60. And we can get the others because we know all the parts. All we have to do is get the totals by doing what? Adding them. So let's just go across first, just because that's what I want to do. 12 plus 8 is going to give me 20, right? And either you can add those two and get your 40, or 60 minus 20 gives you 40. Either way you want to do it, right? Once you start building these things up, then it gets really easy to start adding things together. Right? Coming down here, 12 and 26 is going to give me 38, right? And 8 and 14 make 22. And does 38 and 22 all combine to make 60? Yep. So you can check yourself as you go as well. All right? So in this case, we knew all the parts, so we just added everything together to get the totals. But sometimes you'll know parts and the total, which means you have to subtract to get the other part.
I wrote no foot.
Okay. No foot. Perfect with me. Yeah, doesn't play football seems like a lot to write.
There's not enough room.
Okay. All right. Look pretty easy? Pretty happy? Good deal. All right. Then let's move on. Everybody got that before I go? I'm sorry. Oh, well. Remember, it was just 38 and 22 on the bottom. and what? 20 and 40 on the sides.
I'll just look at his as well.
Okay? Sorry. Remind me. I'm quick on that button, I'm telling you. Okay.
You asked us if we were finished
Are
while
you,
you were clicking.
after I click it off, then I say, are you finished? That's about right, isn't it? Okay. All right. So, here is the completed table that they did for you. You can see in the bold, that's the parts that they put in. Obviously, the 60 was already there. So we were looking for the totals, so we just added up the pieces we didn't know. Yeah? Everybody's pretty comfortable with that? Good deal. All right. Now that we have the completed two-way table, we can use it to calculate some probabilities. Okay? Now we need to be careful, right? And know if we're talking about the entire population of students, in which case they won't give you they won't say a specific person or a specific thing, or if we're just using part of the table. So keep that in mind as we go. We're going to be thinking about this. This one, it says, what is the probability that a student selected at random plays rugby? So, specifically, any student, a specific student, or any student? Any student. So that means that we're talking about out of 60, right? Okay? So that means our bottom number is going to be 60. And where is the column for plays rugby? It's right here, right?
Yeah.
And it's any student, so that means football has nothing to do with it. So that means the total who play rugby, so that gives us 38 out of 60. And that's the way I'm going to leave it, right?
Did not follow that.
Okay. Well, they want to play rugby, right?
Mm-hmm.
Well, this is the column for play rugby.
Yeah.
So what is the total number of people who play rugby?
38.
Out of how many total students in the whole thing? 60.
You're at 38
So 38 over 60.
And he simplified.
Now, they could, so what you were trying to do was use one of those numbers instead of both of them, maybe? Okay. If I was doing this one, those 12 do play rugby, but what else do we know about them?
They play football.
So that's getting more specific, isn't it? Okay. Right now, we want anyone who plays rugby. Okay. So that means they could play football, or maybe they don't. The only thing we can't include is anything from this column, because we know they have to play rugby. Right? So any student who played rugby, so we don't care about football at all. So we just pick, so it's the whole column. Totals. Okay? All right? You're digging the pink. Okay, good. All right. My year 12s picked the pink, and I forgot to change it before. I don't know why I look at this thing like it's got color in it or something.
On Tuesdays, we write the pink.
Okay? But you let me know.
Mondays, we write.
Okay? All right. So, but wait a minute, guys. Is 38 over 60 done?
No.
What's wrong with it?
Simplify.
We can simplify it. We know it'll at least divide by 2. Maybe I'll divide by something bigger. If you divide it by 2, you're going to get 19 out of 30. Will that reduce any more? Nope. So we're done. Now, how else could I write that? A fraction? I could change that fraction into a decimal, remember? And then I could change that decimal into a percentage. Don't forget, there are 3 different ways of writing probabilities. Fraction, as long as it's simplified. Decimal, we don't like it though if the decimals if we have to round them or if they don't or if they repeat. But we do have to change it to a decimal if we want to then write it as a percent. Right? Fraction to a percent, sure, you could multiply it by 100 and get there just as easily. And since, remember, you're all using your favorite tool, the calculator, to help to do the math, so you can check yourself. You can use your calculator here. Remember, it's just a tool. It's not going to make you any better if you don't use it. Okay? It's simply a tool, so use it. There we go. So the probability that a student plays rugby is 19 out of 30. Don't forget, you have to label it. Probability rugby, right?
Do we have to write this?
Kind of looks like an example to me. Remember the rule? If I write it, then it should be important enough for you to. Okay? All right. So the probability that a student plays rugby is 19 out of 30. Everybody got that? I'm about to push the button.
Yes.
Yes? No? Yeah?
Hold on.
Tell me. Okay. We good? Yes? All right. I'm pushing the button. Ah! Okay.
We got it, sir.
All right. There you go. Okay. Here we go. Don't ever let me go faster than you're ready for me to go. So here they're just explaining it. There we are. There are two pieces. 38 students play rugby out of a total of 60 students. And so 38 out of 60. And I don't like that. What did they not do that I am going to get you for? There you go. If you put 38 out of 60, I'm not going to be a happy camper. Okay? Now, what if it was an or statement and we had a probability and then we had to add it to another probability? Don't simplify first because you might need a common denominator to add them together, right? Okay? So I wouldn't simplify first in that case, but your completed answer, your final answer, when you write it down on paper, better be simplified. Yes?
If we have a question like that on Education Perfect, should we put the simplified version?
I think it will. I think it would take the. I think you should put the simplified version. I think it's smart enough to recognize it.
It does say, it does have it shows a tick on the side, and there's a green tick if you actually do it completely right.
Okay.
But it has a blue tick if you have it partly
Almost right.
right.
Yeah.
And then it has like a green tick if you did the entire right.
Yeah.
It does a question mark. It's like what?
What?
You.
Who are you and what are you thinking? All right, here we go. All right, this one's for you guys. Are you ready? Yeah. Yes. Here we go. What is the probability that a student selected at random does not play football? So does not play football. We got 30 seconds. No, the table's there for you. Just read it off this
Do
table.
we need to do it to a decimal or a fraction?
Fraction's good.
No, do we need to draw it?
No, not at all. Not at all. Just read it off the table and put probability not football equals.
Did I do it right?
Or no foot. That's fine. I don't know. Probably they have no feet. I don't know. No foot.
No, I think it's correct. I know, I haven't seen it.
Okay. Good job.
Yeah, I haven't simplified it yet, but it's
Tell me when you're good, guys. You about ready? Everybody got an answer?
Wait, sir, did you also add me to the random name generator?
I don't know. I have to check. Okay. 30 seconds. Talk it over with your neighbors to see what you did and make sure. I want to hear talking here, so I want to see you communicating. Oh, but be careful. Okay. All righty.
Wait, sir, did you actually time 30 seconds?
Yeah, of course I did. Oh, I didn't. Let me put you in there. It's Caroline Musser, right?
Yes.
I was lacking in brain cells. But this year, thanks to a new device called the Mr. Self,
There you
I
go.
am gaining
Yeah,
back.
I'm added.
You are officially,
Probably not said that.
you're officially one of us. Now you have to answer questions. Okay, guys, ready? Claudia. Claudia. All right, so what we're looking at is the probability that a student selected at random does not play football. So what I need you to tell me then is how many students of these do not play football? 40. Do you all agree?
Yes.
Yeah. Now be careful. I don't know what I've just touched
You're
here.
not in annotation.
There we go.
Oh my gosh.
What did
There's a
you
mini
do?
chart in the chart.
So here we go, 40. I don't know what the chart in the chart's all about, but
It's because you drag the
I
chart
drag it
and
around,
you turn
yeah.
it into annotation mode, so now it's just frozen.
yeah. Well, it'll go away in a minute. Right. So remember, it doesn't matter. It didn't say anything about rugby, so we need everyone, the total people who play football. Okay? So that was a question y'all had. So all the way across, the total number of people that played football. It didn't ask anything about rugby at all, right? Good job. All right. Sanari. And Sanari. Okay. I'm always going to do that, aren't I? So what I need you to do then is, can you tell me how many total students are there? 60. Okay. So our finished probability is 40 out of 60. Is that correct, Tessa? No, what's wrong with it? We can simplify it. And remember, if that's one of the easy ones to simplify, we can start by just knocking off those zeros, but what else is common to them? So, yeah, 2, so you're going to end up with 2/3. Are we good? All right. And remember, probability of no football or not football. Don't forget, you must title it. You must put the probability and then some title in there. You can abbreviate a little bit, but don't abbreviate so much that it changes the meanings. That's fine. That's what I put. So here we go. 40 out of 60. And there they go. Not reduced, not simplifying again. But oh well. It's fine with us. Because, you know. Yeah. So we wouldn't like it as a decimal. Why? It's repeating and recurring. Yeah. So it does. All right. So we prefer a fraction. Looking good so far? Good deal. Let's move to the next page. All right. Look at this example, guys. In this example, we want to see that what is the probability that the student selected at random plays rugby but not football? So this time, we're not looking for every student that plays rugby, right? We're only looking for the students who play rugby who also do not play football. So plays rugby. I did it again. All right, plays rugby and does not play football, right?
Yeah.
So we're talking about the intersection of those two things. Not the total down here, right? But the intersection of those two things. And how many people is that? 26 out of how many? But we're still talking about all the students. So 26 out of 60, which will reduce to...
What if you don't play either?
I don't have a category for that.
What if you don't play either?
I don't have a category for that. So out of all the 60 students, they did something. No! There you go. Does not play football. Does not play rugby.
Oh yeah,
That's me.
Okay. Me too.
We do not have a category for that.
But I am playing bowls now.
You're just, like,
So
Are you
cool.
saying bowling or like lawn bowls?
Lawn bowls.
I've never.
My parents.
All right. Let's get back on track. I'm sorry. What is it with this class? All right, guys. Come on. Focus with me. All right. So do you see sometimes you'll use a number from inside the chart. But in order to do that, they have to give you two things inside the chart. So if they just tell you one thing, like does not play rugby, that means the total they don't play rugby, right? But if they give you two things, like plays rugby and plays football, then that means you're talking about a number inside the chart, a part, not the total, but a part of the students. Right? So be really careful and read carefully when you're doing these. Okay? I like the tables too. All right. They can contain data in raw form, like you just saw. So we're just talking about numbers of students. But you can also have probabilities in your table as well. Okay? So look at this example. The table below shows the information about amusement parks and the types of rides and customers over the days. Okay? So they've got all of these different rides. Now notice that it's a two-way table, but it's got 4 pieces of information. 2 ways just means across and down, right? Doesn't mean 2 pieces of information and 2 pieces of information. So we have roller coaster, gravitron, blah, blah, blah. And then down on the side, we have either child or adult. And you probably don't have 0.09 of a child, right? So these are not raw data numbers. These are actual probabilities. But if you'll notice at the bottom, they still do totals, right?
So 0.09%.
Okay.
So
So, exactly. So 9% of the people there were children who rode the roller coaster, right? Now, because they're probabilities, look what the grand total always must be.
1. Yeah.
Remember that this is the total of everybody doing everything, so that's 1. In other words, it is a certainty that every child and every adult did something on this chart, right? So 1. So 100%, or yes, and if it was given as a percent, it would give you 100%, right? So you'll know if they're talking about probabilities instead of raw data, because the total of if they give you all probabilities will always be 1 or 100%. Okay? Right. You can't break people into little pieces, right? Okay?
Basically saying like if you have 5 children altogether, then like
Right.
0.09% of all of them
Yeah.
when on the roller coaster.
So a percent of a number, remember to take a percent of a number, you just take the number of percent times that number, but the percent has to be changed to a decimal first. Or you can put it in your calculator as percent and then times if you know what you're doing. Right? You can either move the decimal, change it to a decimal, and then put it and multiply it. There you go. All right. Let's look at some questions. So here we go. What is the probability that a randomly chosen customer is a child? So, is that 2 categories or 1? It's 1. Child. So that means we want to go all the way across. Okay? So it's the probability of a child is 0.55, or if you want to write it as a percent, 55%, right? So one label always go across to the total. Now, what is the probability that this person selected at random was a child and they rode the gravitron?
Do we have to write this in? 5%.
Probability of child and graviton.
Do we have to write the actual big graph thing? Or
No,
can we just write
you can just write the probabilities and you can refer back to this. This is fine. Okay? So it's 0.05. It's the intersection of those 2 places. Right?
I have a question.
Yes, ma'am.
You know how you said the animal is multiplying them?
Mm-hmm.
Do you have to multiply them here?
Nope, because they've already done the math behind it to get that particular
So 0.05.
thing. Because there's nothing else to multiply. That's the beauty of this two-way table. They've already done all the math part to get the piece, to get it. Right? So the probability of that and that have already been computed for you. So that is the probability of those, whatever those individual probabilities were. So what's the probability they were a child?
So say there was 100 children, and there's 50. Oh no.
All right, well, hold on a minute. So if you knew how many children, well, if you knew the probability for a child and the probability of a gravitron and multiplied those together, it should give you that. Does it? Take 0.55 times 0.21.
Wait, I'm going to times them together. Okay. 0.55 times 0.
I'm a bit confused with the decimals.
It's 0.1155.
Okay, that's not how they got it. But anyway, don't worry about it. The probability is right there. Don't worry about that. It's the probability of that intersection. A child and on the gravitron. Okay? They've already worked out the probabilities for you. That's all you need to worry about. for now. What's the probability the randomly chosen customer was an adult who rode the roller coaster or the gravitron? Now,
6.
we got an or. Adult. So what do we got? Adult, roller coaster, gravitron. Right? So, adult roller coaster is what? 0.15. Right? And gravitron, and it's an or, so that means you're adding them. 0.16, which gives you 0.3.
Hey, I got it right.
Wait, excuse me, I don't understand. What do we have to do? Do we add them?
Yes, because of the word right there.
Ah, okay, I understand.
Remember, or
That's how you
always
get
means
the
you're going to
or.
add them.
Okay.
There you go.
I was like,
Okay.
where do we get the or from?
Yeah. So either one of these. Now, if we did and, we would be what? Right.
Multiply it.
Okay? All right. All right, here we go. So these can be read directly from the table since they're already in probability form, right? So we didn't have to find the number over another number. We already knew probability. It's good? All right. So now we're in your homework. So let's see if there's anything else in there. Yes, there is. We got a little bit more time. No, we're almost done. So what we're going to do is we'll do reduced sample spaces on Monday. It'll be our last lesson before the EOTC thing. So we'll do that. So make sure. So what I'm going to do is I'm going to assign the two-way tables part. Or should I just wait? Do you want to wait since you got the probability tree? Well, remember you still have the trees.
No, we still have the trees.
You still have the trees, and you have the Tuesday.
Hold on. Excuse me. The first one we got to see it. I can do the one line. Excuse me. The first one we got to see it. It was something probability, wasn't it?
Yeah,
Yeah.
It was.
but it was huge. It had a bunch of topics in it.
I did. The one I did was not that bad.
It should have had